Hey everyone, and welcome. Today, we're going to tackle one of the absolute cornerstones of C#, and really all of object-oriented programming, polymorphism. Seriously, think of this as a superpower for your code. It lets you write stuff that's cleaner, way more flexible, and easier to build on later. Let's jump right in.
So, let's kick things off with a question. How is it possible for one single name, let's say a method called calculate, to do a bunch of different things? Like 1 minute it's doing addition, the next it's doing subtraction, maybe even some super complex financial logic, all without you having to write a giant, messy if statement. How does that work?
Well, the answer, as you probably guessed, is polymorphism. This isn't just some fancy buzzword, it's a core pillar of object-oriented design, and honestly, getting a good handle on it is a total game changer for any C# dev. It's the magic that lets our code be both elegant and incredibly powerful at the same time.
All right, so what does this word actually mean? Let's strip away the jargon and get right down to what it is, and more importantly, why it's so crucial for building solid applications.
You know, the name itself gives us a huge clue. Polymorphism is straight out of Greek, and it literally means many forms. And that's exactly what it lets us do in our code. It allows one thing, like a method name, to have many different forms or behaviors, depending on the context.
So the main idea is this. You've got one method name, but it can kick off a whole bunch of different behaviors. This happens because different objects can have their own unique implementation of that method. And you'll see this theme a lot. It works hand in glove with inheritance. The best part? You get to say goodbye to those monster if-else chains or switch statements. The code just knows what to do.
And why do we care? Well, the payoff is massive. Your code becomes way more flexible, you can add new features without having to rewrite a bunch of old code, it cuts down on complexity, which makes your projects easier to maintain in the long run, it helps you scale up. Basically, it's all about building apps that are ready for whatever you throw at them in the future.
Now in C#, polymorphism isn't just one concept. It actually comes in two main flavors, compile time and runtime. They both serve different purposes, and you really need to understand both to use this power effectively. So let's break them down.
First up, we've got compile time polymorphism. You'll hear this called method overloading or sometimes early binding. And just like the name says, the decision about which exact method to call is locked in when you compile your code long before anyone ever hits run.
So how does the compiler figure it out? The rule is actually pretty simple. You can have multiple methods with the exact same name as long as they have different parameters. We're talking a different number of parameters or different types. This unique combo of the method name and its parameters is called the method's signature. That's the secret sauce the compiler uses.
And this code snippet shows it perfectly. Just look at this calculator class. See? We have two methods, both named add, but one of them takes 2 integers, while the other takes 3. The compiler has no problem telling these apart. When you write add 510, it knows you mean the first one. If you write add 510 15, it picks the second one. It's clean, simple, and all sorted out at compile time. Okay, on to our second type, runtime polymorphism, or as it's more commonly known, method overriding. Now this is where things get really dynamic. With overriding, the decision about which method to run doesn't happen until your program is actually running. And as you're about to see, this is all about inheritance.
The key players to remember here are two keywords, virtual and override. A base class marks a method as virtual, which is like saying, hey, any class that inherits from me can create its own version of this method if it wants. Then, the derived class uses the override keyword to provide that special custom version. And here's the critical part. The method that actually gets called depends on the actual type of the object at runtime, not the type of the variable that's holding it.
This example makes it super clear. We've got a base shape class, and it has a virtual draw method. Then we have our circle class, which inherits from shape. It provides its very own override for that draw method. So here's the magic. If you have a variable of type shape, but it's actually holding a circle object, when you call draw, it's going to run the drawing circle code, not the generic drawing shape code. The behavior changes on the fly.
Okay, so we've looked at the two types in action. Now let's pull back for the bigger picture. We're going to put them side by side to get a really sharp understanding of how they're different and, when you should reach for one over the other.
This table just sums it up perfectly. Let's look at overloading first. The decision-making, the binding, happens at compile time. You don't need inheritance for it to work, and its main purpose is to give you flexibility, right? To handle different kinds of input. Now, overriding, that's a whole different beast. The binding happens at runtime. Inheritance isn't just an option, it's required. and its entire purpose is to let a child class provide its own special custom behavior.
All right, let's wrap this up with the key things you gotta remember. First, polymorphism is all about one name, many behaviors. It's the secret to making your apps flexible and scalable. Second, you got two types. Overloading is compile time, and it's all about different method signatures. Overriding is runtime, and it's all about using inheritance to customize how things work. And that last point is huge. Polymorphism is powerful on its own, but it really shines when you use it with inheritance.
So we've walked through the what, the why, and the how of polymorphism in C#. You've now got overloading and overriding in your developer toolkit. So the only real question left is this: how are you going to use this superpower of many forms to make your next project cleaner, more dynamic, and a whole lot more powerful?
Hey, if you found this explainer useful, it would be awesome if you'd like, share, and drop a comment. And definitely don't forget to subscribe to the Global Code Factory channel for more deep dives into programming concepts just like this one. You can also find us over on LinkedIn, WhatsApp, and of course YouTube. Just search for Global Code Factory. And a quick reminder, all this content is for general educational purposes. Thanks so much for watching.